Okay, this is not my waffle iron, but somebody left this waffle iron here. This waffle iron is Jen's. So Jen, if you ever want your waffle iron back, I'm taking very, very good care of it. You can trust me on that. This is a good waffle iron. But there's no shortcut for how to clean out a waffle iron. You just got to take the time to do it right. So this waffle iron has non-stick, which is good. So the reason waffle irons get ruined, in my opinion, is because people who clean houses clean waffle irons, and that's the mistake. You can't treat a waffle iron like a household appliance. It's not like a toaster or like, well, it's got some similarities to toasters, you know, because it gets hot, but also because there's a lot of, delicate stuff on there. So in this case, the nonstick coating is delicate, and there's no good, quick way. See how dirty it is in there? There's no good, quick way of cleaning out the waffle iron, in my opinion, in a way that's not going to potentially damage it. So the only way is you just got to treat it like you would a piece of laboratory equipment, or like a good tool, like a good pneumatic air wrench or something like that, where you take good care of it, you keep the seals intact, and you're gentle with it, because you got to be. And maybe you drop it or something like that, but I'm talking about where the seals are. You just got to be careful with it. Some pneumatic tools are built tougher than others, but if you have the kind of pneumatic tool that's not built as tough as you would like, you're gentle with it, and you just got to take care of it. So that's the way I look at these. They're just they're gentle. So what I did, I mean, they're delicate, and when you take good care of them, it really makes nice waffles for any home bar. So this one, see, I plug it in just to warm it up a little bit, and then unplug it, because when it's warm, you can get the oil off a lot easier. Don't let it get so hot that you're burning your fingers. But after that, it's like there's no magic thing that's going to get your waffle iron clean quick. You got to just sit there with your finger and keep using paper towels. It'll take you like 3-4 paper towels. You can add it, like sometimes I add a little oil. I just add a little cooking oil. And then just to kind of help me get off some of the sugars that have been baked on there. Cooking oil is like a good way of keeping track of it. I would never use soap on this thing. I know they say, oh, it's non-stick, use soap. Nah, I don't think so. Because then the soap taste will get in the waffles. I don't want that. But see, with this, you just take your time. It just takes a long time. You just keep getting fresh pieces of paper towel. Maybe you could use a cloth, actually. A cloth might even be better, like a rag. But for some reason, like using a rag on industrial equipment is no big deal. But using a rag on kitchen equipment is just not something people are comfortable with. They don't want to eat a waffle if it's been cleaned with a rag. The rag may be clean, but it's still a rag. Now, I wonder though, maybe it's shop towels, because shop towels are basically just paper towels, but I don't think they're really, like there's a perception of sterility with paper towels. There's a perception of sterility, like this is something I can have around food. I don't know if it's the color or if it actually is produced in a more sterile environment. I don't really know. Obviously, I don't even think it really matters that much. But for some reason, like I'd rather have a shop rag than this paper. I'd rather have something made out of cloth than paper, because it would give me a lot more flexibility. I mean, it wouldn't shred in there. Let me see if I have a cloth. No, I don't have any cloths. Wait, maybe it's sponge. I'll try a sponge. No, sponge isn't going to work. It's got to be a cloth. All right, well, I don't have a cloth. I need a cotton cloth, and I don't have it. I don't want to use a sponge, because that's like, there's synthetics and stuff in there, and I mean, I'm all right with paper. I'm all right with cloth, but I don't want to use a sponge. A sponge may work really well, but for some reason it just doesn't seem like the right thing to use in a waffle iron. I'm just going to keep using the old old-fashioned paper towel method. You just get it in there, you clean out all the little burn bits, and it takes time, and it's worth it because waffles are incredible. And in my case, I do the smallest batch because, you know, I just make one for, I just make like 2 or 3 waffles, not even 3, like 2.5 waffles per batch. And that's enough. So I don't have to clean it this carefully every single time. But it does need a good cleaning, like, you know, say once every 4th time or so. Once every 3rd time, maybe. You know, it starts getting kind of... Like, some of it's good. Sometimes you pull up a waffle and it's got just that little bit of burnt stuff on it. It's kind of nice. But, you know, that's like just a novelty thing, right? You should at least have a few waffles out of every couple months that are produced on a perfectly clean waffle iron. Because waffles are amazing. All right, so we did a taste test of waffles today. And we tried waffles with strawberries and pancake syrup. Waffles with strawberries and powdered sugar. Waffles with strawberries and no powdered sugar and no pancake syrup. And then a microwave chicken cutlet or a microwave veggie cutlet. My son eats chicken. He might eat, actually, maybe that was veggie. I take it back. I'm not even sure. I don't remember. But anyway, nor do I want to implicate anybody in the future.com. But the ranking was this. The most delicious was the pancakes with strawberries and maple syrup. The second most delicious was the pancake with strawberries. The third most delicious was the chicken. And the fourth most delicious, or in fact the least delicious, was strawberries with strawberries on waffle with powdered sugar. For some reason, the powdered sugar gave it a taste that he didn't like. But if you combine the waffle with strawberry and pancake syrup, plus the waffle with plus the chicken, you have a number 1 right there. Because the chicken alone was already better than the chicken didn't have any competition. So no matter what happens, the chicken's getting in. You see? So the chicken's getting in no matter what. The question is, should the chicken go with powdered sugar? No, it didn't work. He didn't actually have any chicken with powdered sugar. He was careful just to eat the waffles and stuff plain. So, I mean, I'm saying, you know, without the chicken. He just did the chicken once with the syrup. I don't even know if we did it. I don't know if we did syrup without the chicken. No, because he ate it separately. He didn't mix them together. So I think mixed together would probably be the best, but he didn't do that. He was wanting to keep them separate this time just for taste testing purposes. Anyway, so there you go. So the best would have been waffles with strawberries and syrup on one plate, and then chicken on another plate. The chicken, it may seem like strawberries and chicken don't go together, but apparently they go together really well. You know, people who are afraid to eat strawberries with chicken are probably afraid of Rick and Morty. Yep, that's my first time actually really seeing Rick and Morty. Everybody kept telling me to watch it. And I did watch it, and it was really good, and I enjoyed it, but I wasn't in the right frame of mind. Today I was in the right frame of mind, and holy smokes, that show is insane. That show is one of the greatest pieces of artwork I think I've ever witnessed in my life. Top 10, easy. Top 10 greatest pieces of art, in my opinion. Rick and Morty. You gotta clean the outside too. You see, he's gotta get it all. And if you plug it in for a little bit beforehand, when it heats up, it just makes it that much easier to clean. See, this is still like a little hot. just a little bit. Like hot enough, like if I put my hand on there, I wouldn't burn myself, like it wouldn't, but it would, if I held it there for more than say 5 or 10 seconds, I might get a little uncomfortable and want to take it away. So it's about that temperature. And before it was a little warmer, it's been cooling off. So I started with it warmer than that. But you know, it's hard to take oil off of cold machinery. You know, you want to clean the machinery after you let it run a little while sometimes. Same thing when you're changing oil in a car. You know, you want to kind of get it going a little bit to really drain all the goop out. But if you're rebuilding the engine and you're literally just cleaning it out from the inside, the way that you can never really clean it with an oil change, you're doing this. You're doing this. You're cleaning all the pieces. You're you're not just putting in new gaskets. You're cleaning that engine out. You're giving it a new lease on life. And you might bore it, you know, just kind of get a nice smooth cylinder wall and sleeve it. You might not. You might just do a pretty good job and let it show its age, but replace whatever's broken inside, your valve so I have to rebuild an engine now. I've got to rebuild a Polaris 488. So that would be the Subaru or Fuji, the Fuji Heavy Industries 488, which is a 2-stroke, 2-cylinder, 2-carb, valveless engine. So I haven't even opened it up yet, but I'm looking forward to it. I mean, like that's an epic design. And that isn't just an epic design. Coming up with that design is just world-changing. What Japan did, what that engine meant in Japan, how much of the country after World War II that engine was responsible or helped rebuild, helped get building materials to the top of mountains and through cities. That engine ran trucks and small cranes. That engine ran all kinds of construction equipment. That engine ran fire engines. That was a truck engine. So the history of that engine is just remarkable. So when I rebuild that, I'm going to want to film it because that's a piece of, that engine is perhaps, in my opinion, one of the most important engines ever made. I will say that the Straight Six is clearly one of the most important engines ever made just because it's the, naturally balanced and the foundation of the modern contemporary diesel engine. And it was also used in a lot of cars and Jeeps, and Chrysler had a really good run with them. The Slant Six, although the Slant Six I never really got. It kind of lost some of the symmetry of it for my opinion. It didn't. I don't know really I guess there were advantages of the Slant, but I don't really know enough about it. But that 2-cylinder, 2-stroke, 2-carb engine. And I'm sure there's even some fuel-injected versions. But obviously they weren't fuel. I don't think too many were fuel-injected in the 1950s, late 1940s, whenever that engine first came around. But Japan was not trusted the way that we trusted Europe, the way we trusted the people in Germany, and the way we trusted people in Italy, and because the United States was still trying to manage our hatred, our racism. And when we saw Germans and Italians, I think that we just intrinsically trusted them a lot more and it wasn't because there was necessarily anything wrong with the people in Japan, but at the time there were very few Japanese people in the United States. And we just didn't, and they weren't part of the culture at the time. There was a very relatively new immigrant class, and they were people that had come here with a very different economic imperative than the people from Germany and the people from Italy. So, unlike Italians and Germans, the Japanese didn't really have a lot of visibility. And because their features were so different than the European features that the United States of Americans were used to seeing, and Africans, the United States of Americans were used to seeing, that there just wasn't a lot of understanding. There wasn't a lot of exposure, and people looked at them the way, for instance, in Rick and Morty, when Morty's shooting up all these grasshopper people or locust people, these big insect people in the airport in the first episode of Rick and Morty. It's like these are people. They have families, babies. So Morty's this horrible person shooting up everybody. It was just a cartoon. But, they looked at them in that way. It's like that show kind of forced you to shift your perspective a little bit. So Japan, we just didn't trust them with big machinery. So they realized that pretty quickly, that these Americans didn't trust them too much. And to the credit of, I wouldn't say just Japan, but I would say Asian culture, they took a path that accomplished two things at once. It both endeared them to us, and it allowed for their economic development. It wasn't just them being a bunch of bumbling fools and saying, oh, here, the Americans won't be threatened by us if we're a bunch of bumbling fools. They didn't. They produced some of the greatest engineering and science and design that the world had ever seen right after World War II. The whole Asian culture, not just Japan, but China, Korea, and Vietnam, Cambodia. So they took this engine, this two-stroke, two-cycle, this two-stroke, two-cylinder, two-carb, no-valve engine, and they built an economy on it. They put these things all over the place because this one engine had this remarkable ability that it was so relatively simple that it could be made in relatively large displacement of 500 cc's, which was enough. A 500 cc engine could relatively slowly pull a load of building equipment up to the top of Mount Fuji, up to the chairman's house, which is what they needed to sell the product. The chairman of Fuji's house, I believe he lived on the base of Mount Fuji. He had a house up there, or maybe a vacation house or something, and they used this engine in a small truck to bring the stuff up to the top of Mount Fuji, and I think that's what pretty much sold him on it. That if an engine with this truck can get a load of building material and two employees, one person to drive and one person to sit shotgun, maybe even a third person, that this could rebuild the country. And they built wonders with this little engine, this little truck, with a 488 Fuji engine. They rebuilt the country. I mean, they had some other equipment, but it was remarkable what they did with that little engine. So when I break into that engine and rebuild it, I want to video it because there's something remarkable about that engine. There's something just very special about not just the engine itself, but I would say a testament to the Japanese culture, that they took a problem, a specific, definable problem that the United States of America did not have a good relationship with them. And they took another problem, which is that they needed to rebuild their infrastructure and do so in a way that was compatible with their ideas and their thoughts. And they created this less is more approach. And less was more. This little truck engine was about the smallest engine that they could use to do what they had to do, which was carry a couple or even three employees, a load of building materials, and get it up the sides of mountains, and get it out in the plains, and get it out in the ocean, and get it out in the coasts, and rebuild a country with this. We may have had the Ford truck and the Chevy truck and the Ram trucks and the Studebaker trucks and the International Harvester trucks. And we had all these great big trucks, but Japan had the Kia truck. I don't know how you pronounce it. Kia? Anyway, the Ki truck. K-truck? K-truck. I think it was the K-truck. I don't know how to pronounce it. They had this truck, and it's still being made. Daihatsu, I think, still makes them with that engine in it. I think it's probably fuel injected, but I believe it's still the two-stroke. No, I think it's a four-stroke. but it's still the two-cylinder engine. See, that's the thing, though. When you go away from two-stroke, I mean, you have to for pollution, but the two-stroke engine is unfairly maligned. It has this, the two-stroke engine has this perception of being a big polluter. And it is a big polluter, but it doesn't need to be. If you use the two-stroke engine in a contemporary way, it can actually pollute much less than a four-stroke. Now, somebody said, well, how could that be? Because, you know, you're missing, you just have two cycles. You're always going to lose efficiency. Well, ask yourself first, where is the two-stroke engine most efficient? The two-stroke engine is most efficient at, doesn't mean it's more efficient, just the most efficient. The two-stroke engine is most efficient when the harmonic is, well, I guess synchronized is the wrong word, but when the speed of the engine is fast enough to allow a lot of rotations per minute, but slow enough to allow for near complete combustion, so that as this fuel-air mixture ignites, the time that it takes to combust as much as possible, you know, obviously not 100%, you can't get 100% combustion, but optimize that you get the most combustion at the speed that it takes to bring in your new load of air and fuel and prime for that next combustion. So there is an optimum point, an optimum speed, where a two-stroke engine is the most efficient that it can be for a two-stroke engine. Okay. Now, but they will say, the four-stroke people, that's still not as efficient as a four-stroke, because with the four-stroke, we have all of this extra ability. We have all of this extra stuff that we can do. We have the extra two strokes to be able to let the exhaust gas pass out, let the combustion happen a little longer while the rest of the engine cranks. But the two-stroke outputs a lot of power for a relatively small displacement. So what the four-stroke people say is absolutely true. It's 100% true that, where's my spray bottle? Oh, I gotta clean the counter, not the, what the four-stroke people say is absolutely true. They say that the four-stroke engine is always more efficient. Okay? And that is true for the most part. But yet, in a contemporary way, it's no longer true. And the reason for that is, in a contemporary way, we no longer need a gasoline engine to run at a wide range of RPMs. Because the contemporary method is that we're using electric motors to run the wheels, and we're using the gasoline engine to charge up the ultracapacitors and the batteries for the electric motors. So now, all of a sudden, you have a two-stroke engine that gets to do something that no other two-stroke engine before ever had a chance to do. And that's run at a specific, defined, and optimized RPM, and only that RPM, because the engine system doesn't care what you feed it. For the most part, there's some variability, there's definitely some nonlinearity, but we can tune electronic systems much, much, much more easily than something with the complexity of combustion, because combustion is far more complicated than electromagnetics. It's nonlinear, it's non-Newtonian, the fluid dynamics are all over the place, you have combustion dynamics, you have changing temperatures, you have different conditions that it operates in, different altitudes, cold weather, hot weather, different loads. It's just a wildly complicated system. Electrical systems, not so complicated. We can figure those out. We know how to optimize them. We do have to use, sometimes we have to use some quantum mechanics, but that's a tractable problem. There's a big difference between using quantum mechanics, which is tractable, and using Navier-Stokes with a nonlinear, non-homogeneous, non-Newtonian system. It's a different level. One is solvable to a degree, and the other one is solvable with a team of people, and that's the big difference. So, from a mobility point of view, as a scientist and as an engineer, it's easier in many ways working with electrical systems. So we can have this gasoline two-stroke that only needs to operate at an optimized RPM. And that can then charge the ultracapacitors. It can then charge the, move the motors that run the wheels, that charge up that do the regen braking and all that stuff. It can interface with that. Obviously, if it's doing regen, you wouldn't need the gas. But maybe could potentially use it for another purpose. The point is, a relatively small engine is going to output at some degree, if you optimize a four-stroke for that job I just mentioned, which is powering an electric car or an electric bike, and you optimize a two-stroke, the two-stroke will essentially do that job in something like half the displacement. So if it takes you 1,000 cc's to do that job in a four-stroke, you could hypothetically do it with something like 500 cc's in a two-stroke. Now the question is, which makes less emission, which is more efficient? That's when you start looking at the opportunity, the real opportunity of two-stroke, which is as complicated as engines are. At least two-stroke has some redeeming features that might make it very advantageous to use with electrical vehicles. And that's the fundamental opportunity. And that's why people who use two-strokes, who ride two-strokes, who fix two-strokes, have something remarkable in front of them. And that is the opportunity to push the envelope, to push the boundaries, to stretch the envelope, to find some profoundly new ways of interacting with engines. Because, and I'm not even talking about fuel injected. I mean, I'm talking about simple two-strokes. Simple two-strokes, as simple as my Fuji 488. Carbureted, no valves, just a simple engine. Because with that simple engine, your variability is now coming through the electrical circuit, because that's the one that gives us a lot of latitude, because we have a lot of latitude to change the capacitor array. We have a lot of latitude to change the battery array, to put in less batteries or more batteries if we want to lower the weight. We have the opportunity to put in more motors, less motors, change the size of the motors, set up the regenning circuits. We have the opportunity to carry more fuel, less fuel. There's all kinds of things we can do with a system like this. But we no longer are stuck to trying to optimize just the gasoline engine. We can take a relatively simple two-stroke engine and then make the adaptations of the system by the way that engine interacts with the electrical charging system. And that's where the tremendous opportunity is in two-strokes. So the people who use two-strokes and ride two-strokes and love two-strokes, don't give them up. Don't think that there's not a future in two-strokes, because in my opinion, and I could be wrong, so make sure you know how to fix four-strokes too. In my opinion, there's a future in two-strokes. That's my opinion. I think that we're going to see a two-stroke engine that is efficient, clean, inexpensive, and the perfect candidate to charge up electric vehicles for the next 20, 30 years, while the electrical storage and electrical generation infrastructure and electrical transmission infrastructure mature as we transition away from fossil fuels towards renewable ones. I think that natural gas has done a tremendous job of letting us move away from some of the more polluting methods. I don't want to get too political, but some of the more polluting methods. Natural gas is obviously, it still has pollution, nitrogen, oxygen compounds, and it's still a carbon emitter. You know, there's global warming and all of that. But natural gas has been a friend. At least our skies aren't dark. At least we have a chance of catching certain respiratory illnesses that we may not have had a chance to catch before. So the other friend, I believe, are very small displacement two-stroke engines that will allow us to leverage our investment, our societal investment in gasoline for the next 50 years, maybe even 100 years to a degree, depends how long all of this takes. There's a lot of socio-political issues, rare earths that we have to obtain, and plastics that are polluting the planet. There's a lot of things we have to figure out as far as industry. We want to leave this planet to be a healthier, happier, cleaner place for our kids and for our grandkids. So we have to figure things out. But in the meantime, while the grid catches up and the generation catches up and the storage catches up, because storage has not been a big component of our electrical grid, while the storage catches up, we've always been very good at storing water. We've never been very good at storing electricity, I mean, except for we do have some compressed air storage, one big one in the United States in McIntosh, Alabama. There's also one in Hunsdorf, Germany. But we're mainly about storing, when we store energy, we tend to store it as water, pump power, but also if there's water up in a dam and we have a spillway generator, we can use the energy when we need it, when there's a need, letting the water go down. That's used quite a bit on the East Coast, less so on the West Coast because we don't have as much water as they do. But we don't have as many small sources, just mostly a few big ones, and the small ones aren't too good for making power. But the reason the electrical vehicle is so far ahead of generation, the reason the electrical vehicle is so far ahead of distribution, and the reason the electric vehicle is so far ahead of storage is because the electrical vehicle's been around for a long time. It's been around longer than the grid. It's been around longer than it's been around longer than, well, okay, so it was pretty much at the beginning of storage, because one of the first electrical vehicles, which I believe was built in the 1800s, had lead nickel batteries, I think. I'm not positive which batteries it used, but it's been around a long time. The electrical vehicle has been around as long as the gasoline vehicle, or very close to as long. I'm not sure if it's been around a little longer or slightly less time, but it's been around for a very, very long time, as long as the internal combustion engine, perhaps a little longer, perhaps a little less, I don't remember. But the electrical vehicle has been around for a long time. But the infrastructure wasn't there. We had the infrastructure for gasoline. We could move gasoline, we could move kerosene, diesel by trucks, but we didn't have this profound and robust electrical distribution infrastructure the way we do now. So the ability to ship enough power to keep an entire city's electric cars running, I believe right now might be a little bit beyond us. I'm not positive of that, but I suspect that's the case. I don't know if the grid can handle that yet. I mean, there's probably a lot of links where we need to replace old-fashioned conductors with superconductors like they're doing in Chicago. And there's probably some areas where we need to put in some long-distance DC transmission lines. There's probably some opportunities, for instance, in connecting Texas's grid to the rest of the economy, because the rest of the grid economy and the rest of the grid, because Texas is doing some really awesome and advanced things in wind generation and solar generation. And the rest of the country really could learn a few things from Texas as far as being advanced energy. Texas is, their distribution is one of the best grids in the world. Their electrical production is one of the most progressive, and arguably that might even be part of the reason people blamed the recent Texas outage on. They blamed on renewables. I don't know how accurate that is. I'm sure there's probably a little bit of an issue, but the renewables, even in Texas, are not a huge component. There's still a lot of fossil fuels, if not most fossil fuels. I know there's not that much water in Texas, so it's probably coming from a lot of fossil fuels. Mostly natural gas, probably still some coal. I think there's a couple nuclear plants. Nuclear is on the way out. It's been very expensive, and we're thank heavens we're moving away from a world that relies on nuclear weapons to speak to people. So that's been a positive change. And because of that, nuclear energy now has to pay for itself. It doesn't get to piggyback on weapons generation. But regardless, there's a lot of opportunities in the grid to catch up to these electric vehicles. And there's also a lot of opportunity in storage to catch up to the electric vehicles, not just in storage on the vehicle itself, because these Teslas and Leafs are essentially have their own storage built in. Arguably, the way they could interface with the grid is as storage, so that when you drive your car to your office building, if your office needs a little more power to do an extra air change, but it's legally mandated minimum number of air changes per day, or per hour, I should say, it might be able to draw power. The building might be able to draw some power from your car at peak loading time, so the rest of the grid doesn't freak out. You know, it's part of the whole smart grid thing. Great. Okay. There's a lot of opportunity there, but storage is really in its infancy compared to the grid and compared to generation. Electrical storage is incredibly difficult, and we have a long, long way to go. Now, we do have great batteries, that's true, but the infrastructure of how we build these batteries is still young. Right now, they need rare earths, they need some very difficult to mine metals. They need things that unfortunately can create political instability and can negatively impact some of the most delicate cultures on Earth. This is a major issue of how electric vehicles are going to have to relate to the health, happiness, and overall wealth of our planet. If the goal is to spread happiness as far and wide as we can and spread health as far and wide as we can, then we're going to have to look at how do these electrical cars interface with these needs of the world. And this is relatively new. We haven't been mining rare earths out of the ground for that long. We haven't been mining cobalt and stuff out of the ground for that long. And in some cases, there may be clean ways of doing it. In other cases, we maybe should reduce the amount that we rely on some of these elements so that we can move to more efficient ways of extracting them out of the ground. And that's my area. So this whole video is not an advertisement for my company, but that's what I do, is I have novel ways of extracting the rare earths out of the ground. And so do other people who work with me. That's our job. And we hope that we can help the low entropy power and the low entropy communication, which includes transportation, obviously, industries advance in a way that's managed to spread around the most health and the most happiness that can possibly be spread. Okay, so in doing that, the two-stroke has a place. And when I clean out the two-stroke, I'm going to video it, at least try the same way that I videoed cleaning out this waffle iron, because I believe I've shown this waffle iron a good amount of love. I should probably take a brush and get out all the crumbs of the paper towels. They get floppy. They get wet. And of course those I think I may have been cleaning. I may have used some of my pine oil on the counter there. But no, see, this still needs some attention. Look, it's a long process. Cleaning out a waffle iron. Okay, yeah, it's true. I was talking for a while there and I wasn't cleaning. I admit that. Okay. But still, this video has captured most of the experience of cleaning out a waffle iron, and I'm still not done. There's still little bits of food in there. There's still little bits of oil, and it's still not perfectly clean yet. And the other alternative is using a sponge or something, or some kind of crazy brush, and cleaning it out that way. See, I'm getting lint off of this thing. I think if I had a cloth, that would make this job so much better. I think it would really improve it. Hey, wait, I have a cloth. Okay. Is that cowboy enough for you? Is that cowboy enough for you, Cookie? Is that cowboy enough for you, Cookie? I'm using my bandana to clean out the waffle iron. But you know what? My trail mates deserve it. They worked hard. They deserve to have a clean waffle iron. This makes all the difference in the world. using a cloth instead of a paper towel. Look, I know, here's the reality. Most people are not going to use a cloth. There's just like this thing, like you just can't use a cloth on a waffle iron because people are going to think it's a rag. But you know what? It's the only right way of doing it. That's just the reality. You can't do it with a paper towel. See, this is making the job so much easier because it's not leaving the lint all over the place. But you know what? The first step was good. I got most of the rough stuff done with a paper towel, and now I'm just doing the final polish with my bandana, and it's not getting full of oil. It's staying relatively clean. I could probably put it over my face and smell the delicious smell of pancakes all day. Make me think of my girl back in town. How's that song go? Rollin', 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 rollin'. Gotta keep them doggies moving, though they disapproving. Keep them doggies moving, rawhide. Don't try and understand them, just rope 'em, rod and brand 'em. Is it ride or rod? Soon we will be living high and wide. Hit 'em up, move 'em out, hit 'em out, hit 'em out, move 'em up, rawhide. Hit 'em up, move 'em out, movement, ha! Movement, right in! Rawhide. All them things I'm missing, good loving, hugs and kissing, waiting at the end of my ride. Hit 'em up, move 'em out, hit 'em up, move 'em out, rawhide. Wait, what was the one with the dad who took care of the kid? His wife died of the pox. Wait, died not of smallpox, cholera. I think his wife died of cholera, and he was left with just him and his son. The Rifleman. How's that music go? The Rifleman. That's what I'm like. I'm like the Rifleman. All right. See, look, here's the thing. In the Rifleman's house, I think, what was that dude's name? Anyway, the tall basketball playing dude. Chuck Connors. Chuck Connors. I think that the Chuck Connors dude, I can't remember the guy's name, the character in the show. Anyway, Chuck Connors, what's that guy's name? Gavin McLeod. No, that was Love Boat. It wasn't Gavin McLeod. Anyway, the Chuck Connors character, if he saw his son looking over, cleaning the electric waffle iron with his bandana, first he would be like, hey, where did you get electrical grid to run that waffle iron, boy? And then he would say, good job on cleaning the waffle iron with your bandana. He wouldn't be like, oh, that's not clean for eating. You see, because he's a dude. He doesn't care. It's clean enough. All right, there you go. Clean waffle iron. Look at that. That is a clean waffle iron. See that? I'd say it's pretty dang clean. You can't rush a job well done.